Okay. Hello, everyone. We're live. Sam is still muted. Hello,
I'm
Vincent. So
back.
nice to have you on board. And thanks a lot, Cyril, for joining us today. Very excited to hear about all your expertise and knowledge.
Thank you.
We can see that we already have some people on board. So just as a little intro, today we'll have a little LLM, well, not little, we have Cyril, AWS Machine Learning Hero here. We'll have a LLM crash course by Cyril and also some context into the current state from Serverless Sam. So I'll leave it up to you, Sam. We can get started. Thanks everyone for joining. Hope it's as
Perfect.
interesting as it's for us.
Yeah. Okay, Jonathan, I think we can put up the slides. And we'll have a slow introduction. We've got maybe a minute or so before we let Cyril loose with his crash course. So we'll give people a little bit more time to come in. But anyway, let's sort of get things kicked off. So yes, our Serverless Guru Holiday Hackathon. So this webinar is by no means tailored just for people doing the hackathon. I think anyone's going to learn an absolute ton about LLMs and Gen AI and whatnot from the next hour or so. That's okay. So a little bit what we're going to do today. We're just going to give you a bit of context as to who we are at Serverless Guru, just a little bit about the hackathon. We're going to let Cyril loose for about 30 minutes or so, and then I'm going to sort of round everything back with sort of the developer hat on for what does all of that mean? How can we use all this stuff that Cyril's going to enlighten us about in things like hackathon projects, chatbots, whatever you need, and then a Q&A at the end. So let's just start very quickly, a little bit about us, who we are. We develop, we consult, and we educate in the serverless space. Serverless Guru's got over 75 engineers scattered all across the globe. We serve clients big and small. So whatever point you're on your serverless journey, Serverless Guru is there to help move you in the right direction. We also run hackathons. So yeah, that's fine. We also run hackathons, as you might well know. We've had some big news come out this week for the hackathon, which, by the way, is starting today, or may have technically started now. I'm not sure when the technical time to start was. We've announced our judges. So we've got four key personnel within the serverless space to judge all of our hackathon projects. We've got Yang Kui, the independent contractor podcast extraordinaire that he is. We've got Rossius as well, who does have a history with Serverless Guru as well, and he's now off building his own educating platform. Both of those AWS serverless heroes. We have Cyril. Cyril's on the call with us today, an AWS machine learning hero that we have here at Serverless Guru. And then we got Manoj Fernando, based out in Sri Lanka, an AWS community hero. He does a ton of help in the educational space. He churns out YouTube video after YouTube video and helps run so many meetups in and around that area around Sri Lanka. We're also going to be sharing some content that we think will help you through the hackathon, but also through your generic journey into LLM and this new Gen AI explosion that we're all witnessing. So to start with, we had Sankara, who another one of Serverless Guru. He produced a sort of a getting started article on Bedrock, which includes some important things like how do you even get it enabled within your AWS account, and also how can you get going with some coding solutions. So we share all of this on LinkedIn and Twitter, and there's going to be a ton more coming out over the next couple of weeks. So make sure you're liking and subscribing and whatnot. Get all that content as we reveal it. So enough with the introductions. I'm going to turn the focus to Cyril now, our AWS machine learning hero, to give you 30 minutes into an LLM crash course. So Cyril, welcome to the webinar.
Okay, thanks so much. Yeah. So it's good to be here. Let me try to get my slides on. Okay. So I hope I am live now. Okay. So yeah. Okay. So let's get it. Let's roll.
You're good. You're good.
Yeah.
Okay.
Good to
Over
go.
to you.
Yeah. Yeah, good. Okay, so you put me on the spot, you want me to do LLMs in 30 minutes. That's not an easy thing because there's so much to talk about. But let me see what I can do in 30 minutes by giving a high level overview of especially where we are at today and where we come from and where we are heading to, because there's been a crazy rush, I think, from 2022. And so we're just going to go and talk about some of the discoveries and where we are today. So, who are I am Cyril, a machine learning hero. I'm also a serverless developer in Serverless Guru. So I've been in the analytics space now, machine learning space, data science, and all that for more than 12 years. So I'm also the owner of the YouTube channel Data Science with Cyril. So you can always reach me through my LinkedIn, Twitter. I'm always open to have a conversation with anybody related to these topics and more. So straight to the agenda, we are just going to do some light introduction of language models. That's how it started, not large language models first, because we have been having things like Google Translate for some years now, even though they have been getting better over time, but they have been existing for years, as you would see. Then we are going to look at the key features of LLMs now, what it's hot right now and it's all over the place right now, and a little bit of how LLMs work, just a brief overview. There's a part where Sam is going to get into some detail, get into some of the racks and things like that. But I'm just going to stay top level, especially as we have lots of beginners and people who are confused. And then we're going to talk about some of the challenges with LLM. So we get to see it's not just like a one size fit all solution. We have to be careful. And then some ongoing research, which is linked to kind of the future and also what we expect to see. So we are still moving. It's not yet over. So we're still on the road. Now, before we start talking about large language models, I just want to drop this because there is always that confusion of Gen AI, LLMs, wherever I'm talking about LLMs, wherever I go. So first of all, there's the broad AI, artificial intelligence, which is anything a machine is trying to do that humans do, for example. Then you can have machine learning, which is that sub branch of AI, which uses probability, data, and it's the most popular. You could also have robotics, that's the non machine learning part of AI. So it's not always only about machine learning under AI. Okay, but now we are under machine learning, which has to do with data, the machine using past data to be able to predict somehow the future or create new data like we would see with Gen AI. Now we are on deep learning. So deep learning is that part of machine learning that uses neural networks. So there are other types of machine learning that don't use neural networks. If you maybe looking at the machine learning space, you could look at things like linear regression, XGBoost. They don't use neural networks, but deep learning use neural networks like convolutional neural networks. You have things like recurrent neural networks. That is deep learning. Then we moved on to come up with a sub branch in deep learning called Gen AI, which is now being able to create content, trying to create content, some original that should look like something original. So that's Gen AI. But you have other deep learning that are not necessarily there to create content. Let's say you want to do a face detection or some other thing you want to do, which is not necessarily to create a content. Maybe self-driving car is not creating any content. That's other deep learning. But Gen AI is about creating something new just from data. Then again, we can go into Gen AI, and now we talk of LLMs, which are the large language models, which have to do with language. That's the key difference here, because it has to do with text, how we speak. And you could also use GANs, generative adversarial networks, which is mostly to do with images, pictures. So large language models has to do with how we speak, GANs will do more on how we see. So I just wanted to get this clear before we start getting lots of questions on what is Gen AI and what are LLMs. Okay, now that we are good to go, let's roll. So what are language models? So by Wikipedia, a language model is a probabilistic, yes, probabilistic, that's the keyword. Now we're talking about machine learning. They're using data, trying to use some calculus, trying to use some probability again, and trying to predict the future based on probability. So it's a probabilistic model of a natural language that can generate probabilities. Yes, we're talking about probabilities, predicting maybe with 98% accuracy that this is the next word you're going to say. For example, in a series of words, again, it's text, it's not images or videos, it's text. So based on text corpora in one or multiple languages it was trained on. So it could be a translation from one language to another, or it could just be question and answering in the same language, but it's all about how we speak, again, not how we see. So we have things like speech recognition, which are some of the applications of natural language programming. Language models, we can use them to recognize speech. You can look at services like Amazon Transcribe is an example, which is able to get your voice and then bring it down to text and even distinguish the speakers from the different voices. Speech recognition, it has been there for years. Even from the name Amazon, not even AWS Transcribe, you can see it's been there for years. But the underlying models have changed, but it's been doing that service for us. So we also have machine translation. Of course, Google Translate, again, as I said, it's been there for years. It's not been accurate as it is over the years because of the evolution of the models, which we are going to see. So back then it was using maybe just the other deep learning models, but now it's using the Gen AI models and it's only getting better, for example. So you can have things like Amazon Translate, again, which have been there for years, and the name Amazon tells you it was there for a long time. For translation, that's straightforward. We have handwriting recognition as well. So being able to recognize handwriting, Amazon Textract is an application for that. So if you're used to AWS services, you maybe know that already. We can also have natural language generation, which is something which is getting really interesting more as we get into the Gen AI space. So Amazon Comprehend can help us with that, with other services chained. And then we also have information retrieval, which Amazon Comprehend can help us as well. So if you're in the AWS space, you would understand this. Now, let's go to the evolution to see where we are coming from. So the first milestone, there could be more. It could lead back to Plato. So it could go right back to that BCs. But in 1967, this MIT professor came up with this model called ELIZA. And the whole thing about ELIZA was that it was just using pattern matching and substitution, not complicated things like we have today. And that was not enough. Yes, we moved to recurrent neural networks. So the whole thing about recurrent neural networks was we had to be able to capture sequences, sentences. I am going to maybe school, to work. So you had things like convolutionary neural networks, which was, think of them like static. It's not capturing a phrase. It's just a static image. Okay, there are this number of objects in this image, for example. But now, recurrent neural networks, we are able to look at a sentence or a phrase. But then we noticed that they could only do short sentences. That's why in 1997, we moved on to LSTM, long short-term memory, just like the name implies, long short-term memory. So there's a memory. So the model can now remember a long sentence. I went to school, I bought this, and then I came back and maybe the he had been referred to in some paragraphs before. So it's able to remember the name of the he, and this he in this case was John, and he met me as well. So the long short-term memory came on in 1997. But then it couldn't do very long sentences again. We always pushing the envelope because it was kind of like sequential. It wasn't able to parallelize, and we had to, whether back then we're thinking about distributing our workloads. So then in 2017, that is when this whole thing started, transformers. And if some of you would have heard, the paper "Attention is All You Need" is what got us to where we are today, because transformers are still the state of the art right up to today. And maybe next year, this year, I don't know, somebody else would beat transformers, but transformers are still the state of the art because they can take billions and billions of parameters. The sentences can be as long as you want. They are having now the ability to parallelly distribute this workload, so which means the training times can be faster and it can be more efficient as well. So you see in 2018, when you look at GPT, what does it mean? Generative pre-trained transformers. There's transformers in it. So from 2017, the T in GPT, whether GPT-1, GPT-2, GPT-3, it's because of transformers. So we have GPT-2 coming up in 2019 with Roberta. 2020 GPT-3 still again transformers at the end, the T. And we have GPT 3.5, Instructor GPT, and this was the golden year 2022 when ChatGPT came out. So it feels like ChatGPT just came out of the blue, and I mean it's new, but it's been an evolution, and it still keeps moving, as you would see towards the end of my talk. So we had now the ChatGPT, which is actually the dialogue optimized LLM, simply put. So it was all about pushing more and more for more training data. GPT-1, less data compared to GPT-2, GPT-3, more data compared to GPT-2, GPT 3.5, and of course, GPT-4. And we are waiting for GPT-5. And again, it's going to be using more training data. So in 2023, we had GPT-4, BAD, and Bedrock, which I know Sam is going to get into more details about Bedrock, but I hope we get the flow and we are not too scared, or we are understanding where we are coming from and where we are heading to. So let's look now at LLMs, given that we've seen what language models are. So a large language model is a type of language model, of course, but larger, and it's notable for its ability to achieve general purpose language understanding. So general purpose is very important. The other deep learning models would be focused on maybe just sentiment analysis, maybe just classification, just one specific task. But think of ChatGPT as an example of the LLM chat application with LLM. You can ask it almost anything. So it's a general purpose language. That's the difference, though. Now, LLMs acquire these abilities by using, again, massive amounts of data. This is one of the key things. Data kept on getting, we had the exponential growth of data. We have the statistics of every 2 years, we double the amount of data we have in the world. So with all the smartwatches, the CCTVs, social media, so the data just kept going up, and LLMs was just a natural evolution. Now, you can see here again what we're saying for the GPT-2, just it needed 2 billion parameters. So again, if I want to look at parameters compared to, say, a traditional machine learning model, you can think of them like columns in Excel. So you can have an observation, maybe an individual named John or an individual named Mary, and he or she, we can say column 1 is the age, column 2 is the sex, column 3 is the parent's name, the father's name, the sister's name, the work, the position, the salary. So all those columns, if you want to imagine that, you would have 2 billion of them in GPT-2, have 175 billion of them in GPT-3, and of course 1 trillion in GPT-4. Now you can imagine what GPT-5 would have. So it's all about the number of parameters and also the size of data that they have been training these models with. So these are leading us to the key features of LLMs, which is the fact that LLMs are typically trained on hundreds of billions of parameters compared to the language model. So this is large. It is really large. And the training is done with unlabeled and unstructured data. So you can have labeled data you give to the machine and you say, okay, this is a cat, and this is not a cat, this is a cat, it's not a cat. But unlabeled data, we throw the data to the LLM and the LLM figures it out. So, and the data most of the time is unstructured because text is unstructured. It's not like an Excel sheet with definite columns, numbers, dates, and maybe classic observations or objects. So here we have to ingest data from sources like the internet, Wikipedia, lots of sources, because we need that massive amount of data to train the models to be very dynamic as their general purpose. And we use deep learning models. Again, remember, Gen AI is a subset of deep learning models, and for large language models, we are using Gen AI models. And transformers, again, is what got us to where we are with the latest buzz and the latest development. So transformers was able to help us distribute the training process, and that changed everything. So we have very great performance with LLMs when we compare them to our traditional natural language programming models. And also, again, most models in the LLM space, they use self-learning. So again, the unsupervised learning and also fine-tuning, which I would also briefly talk about in this our crash course. And they are very flexible and, again, general purpose. So these are the characteristics of LLMs. And if you have been using ChatGPT, for example, which most of us have, we must have seen these things like this, and we are certain these are what make the LLMs different from maybe the large models that we have encountered some years back. Now, let's look at again some of the applications of LLMs. Some of them you've already known, you've used them. Some of them we just like reinforcing again. So chatbots, as we are talking about the hackathon, this is a very popular application of LLMs. You also have your content generation. Again, so we go there to build our CVs, write letters, things like that. Language translation, it's getting better, as I said, again, and code generation as well. So we're talking about LLMs taking over developers' jobs, things like that. It's because they are doing that. We get some good code generation from LLMs. So, and sentimental analysis. So let's go straight to our chatbots. So this is one of the most popular applications of LLMs, and it is seeking to understand especially how people ask and answer questions. As you're going to see in the hackathon, you're trying to simulate a Santa, and you're going to ask a question to Santa, and you're going to get a ho ho ho. Yeah, this is the response. So it's chatbot, and it trying to provide a similar response to human, to what Santa would say, for example. And then again, it uses deep learning models, especially Gen AI, and you can also fine tune it for domains specific like finance, education, and that's what we're trying to do here. We're trying to fine tune it to Christmas. So chatbot is a very popular example application of LLMs. And now let's look at content generation. So we can also use our LLMs to generate blog posts, articles, and product descriptions. If you have experimented with ChatGPT, you should know that. And we can capture even the tone, style, and reproduce contents containing a certain genre. So you can even tell GPT, okay, write. You can even tell ChatGPT, okay, write this letter with a friendly tone and or positive energy, or so. It's going to do that for you. So it's interesting. And you can also generate some personalized contents for different types of clients. Again, you say, okay, write this for maybe premium customers, for average, low value, you get that. Really interesting stuff here. And also language translation, like I said, it's revolutionized the translation process. It's been there for some years. Sometimes we use Google Translate and then we have to give humans to check, but now it's getting more and more accurate because we are using Gen AI under the hood. So it's generating, again, more accurate and more human-like translations with maybe little need for a human to verify them again. And then it understands different language structures. Think of the different language structure from Japanese, English, French. It understands all of those structures and is able to translate them even more accurately with the LLMs. So we can also talk of code generation. So it assists software developers. Many developers are using things like ChatGPT, LLMs in general, to be able to get some assistance, translate code maybe from one language to another. There's so many things we use. So, and it generates code snippets for you, identifies and helps fix errors. You can throw it, okay, I get this error, what could be the issue, and it's going to propose possible solutions. You try them out, and probably one of them is going to work. And you can offer suggestions. So for completing code, you must have seen things like Code Catalyst, Google Code Pilot. So there are lots of interesting applications of LLMs. And then we can talk now about sentiment analysis. So it helps to understand emotions, opinions, intentions, and also we are using it for customer feedback and getting market research, content moderation, lots of stuff for sentiment analysis here. So you can easily understand your context, and at the same time, it can handle multiple language and the sentiments while it's giving you your feedback. So let's look briefly at just an overview. So how LLMs work. There is the pre-training, like the first step. Then you have the fine-tuning, like the second step. And you can have now the in-context learning. So most of us are used to in-context learning. I mean, in some way, maybe not intentionally, but let's move on. So the first here is a pre-training. So this is where the model gains the understanding of the data from the vast data set that you expose it to the Wikipedia, the internet. So it learns all the grammar rules, the linguistic patterns, the reasoning. And again, it uses unsupervised learning. So it helps it now to absorb all the intricacies, all the language slangs and things like that without any instructions on your part, because it's unsupervised learning. So it's a lot. We don't want to go into detail about unsupervised learning, maybe another time, but it's just about, think of it like you can have supervised learning and unsupervised learning. And in this case, unsupervised. So it does it on its own. Now it's able to use the masked language modeling, which is masking some words. So I am going to dash tomorrow. So the model has to guess, maybe to work is 90% of the time, or to school, or to, so that's just a brief overview of it. It masks words for itself, and it tries to guess those words on its own. So masked language modeling, so that this helps it to understand the context. And then it also leverages the transformer architecture. So we don't want to go into detail about how the transformers work, the attention, but it uses the transformer to be able to do all of that parallelly and efficiently as well. So the transformer attention mechanism considers the entire context of the whole paragraph or the whole story, the whole content you've put in. It understands everything, and then it tries to prioritize certain parts. So we just want you to understand that that's how pre-training is done. And fine-tuning then is usually the next step after you get the pre-trained model, foundation model. Now it's now like you're moving to the university. So the training was like the whole from your primary school right till maybe you're getting to college. And now fine-tuning is like you're in the university trying to specialize, maybe like a doctor or an accountant or a developer. So it hones its skills, so for a particular task or domain. So it's now specific to this specific domain: Christmas, filling, finance. So it uses transfer learning in this case. So transfer learning now takes the pre-training understanding and it tells it now to your specific tasks again. And then you also have your task-specific data that you provided with, you input it with your finance data, your health data, you point it to your model, and so that it's more specific on that task, because before it was just a general model when you were doing the training. And then you have gradient-based optimization. So it uses that task-specific data now to reduce the loss. I don't want to go into calculating the loss, like using your gradient descent or things like that. Let's just say there is a loss, and the lower the loss, the more accurate your model thinks it is. So it uses that to be able to optimize those hyper parameters, to be able to say, okay, I think this model is as accurate as I want, is good for production. And now we have the in-context learning, which is the prompting now. So it's just like on-the-job training. You've gone to your early education, you've done everything, you've gone through your preschool, gone through kindergarten, started your first grade, all you've gone through all of that, and now you've gone to university. Now you're in the job. You're not really going back to school. You're not changing parameters here. You're like, okay, this is how we work here. In another company, this is how we do things here. So it's on the job training. And so it is guiding the model's behavior with well-designed prompts. So you have the prompt, you prompt it, you design your prompts so that the model is able to give you an output in a specific manner. So this does not alter the parameters of the model, or it doesn't even use specific task data. It's just you ask it questions in a technical way, so it's able to get the point and next time respond in a technical way as well. So it does not require you to understand deep learning or machine learning or have a knowledge of all the AI. It's just about asking the questions in a technical way. And so it does not use any additional compute resource apart from the inference resources, because you're just like a consumer. Okay, where am I going to, or things like that. You're just like a consumer asking questions. You're at the point of doing your inference. You're not training the model anymore, but then it's still learning. That's why we call it in context learning. So the model goes from understanding to providing context relevant responses, which is relevant to you, to your content. So two more things to say before we go. Let's look at the limitations. So it's not always a one size fits all. So it's more expensive and slower to your response time for LLMs. If you've noticed, at times you ask a question, you have to wait a couple of seconds before you get the reply. So, and it's also more expensive to build LLMs, of course, using lots of GPUs than the other traditional models. And we all maybe have seen this, or it's the biggest thing we talk about with LLMs, hallucination. It can give you a wrong answer with all the confidence and maybe derail you. So that's it easily hallucinates. And as you would see, it's one of the ongoing research priority to try to reduce this hallucination. We hope it will be done in future. And you lack of explainability and transparency. So you can't really explain why you got this answer. And yeah, you can't really like clearly go and say, okay, these are the criteria I use for the 1 trillion billion parameters, and that's why I chose you as maybe the winner. I don't know, or I recommended this product to you. It's kind of complex. So it has a potential bias for training data set. So there is this issue if more of the data is for some specific, more of the digitalized data might be from the developed worlds, for example, more than the developing countries. So the developing countries might have a kind of biased response, or some social groups, some groups of people, the response might be biased because garbage in, garbage out for machine learning. It can only say what it knows. And there are also concerns about data privacy. We have some companies who have temporarily suspended ChatGPT from their office premises or things like that. Again, we all must have heard that. And we have this risk again of prompt injection attacks, which is the well-designed prompts, again, like the in-context learning, or trying to like, you can, if you've been a programmer or if you've been a developer, you know, SQL injection. So we are trying to use prompts to get some private data, maybe some data that's in the database. So there's this risk. And so those are some of the limitations. But then the future is there always. We stay positive. We still on that train. We saw the long line right from 1967. We're still going to keep moving forward. So research is on measuring and reducing hallucinations. So we're for the AWS reInvent, and there were some announcements of Claude 2.1 bringing down hallucinations, for example. So there's lots of research going on in this direction, and we expect to see that in the coming years, less hallucinations from our LLMs. We are also, research is also working on trying to incorporate other data modality. That's the multimodality, where you can drop text. Let's say you're in the hospital, a medical analysis, you have some X-ray photos, you have some patient history written down, you have some pictures, you have some videos, audio, I don't know, you could just drop all of that in the model and it does the thing. So that's the multimodality we are still working on. And lack of explainability and, okay, this, yeah, that should be a typo then. We are looking at, let's go straight to making LLMs faster and cheaper. So it's, they are trying to make LLMs faster, as we spoke about the response time, and also the cheaper also, if we are able to train the models half the time, most of the time using the cloud, the cost will be half of the cost or even less. So the faster we can do the training, the cheaper it gets. They are correlated. So we are also thinking of developing GPU alternatives. So if we can, we've been using GPUs, training has been on GPUs ever since Transformers. So maybe TPUs, before it was CPUs, now we are stuck on GPUs. So maybe this year, next year, I don't know, something else will come up and GPUs would go down and that thing will be faster and more efficient than using multiple GPUs. Maybe put down the cost at the same time. So most of them are kind of interrelated. It's also going to trying to improve the efficiency of some of the chat interfaces. So writing to you on WhatsApp, at times I start a phrase and then I drop another phrase and then I say again. So with the current chat interfaces, you have to write everything all at once, send and wait. So maybe in a couple of years now, you could be able to chat with it just like you chat with your friend, and there might be some other things I'm not even able to imagine right now. So that's it. I hope I was able to do that in 30 minutes. Put me on the spot. Thank you.
No worries, Cyril. Thanks for that. Really, really enlightening. I think things like the scale of the data, the amount that it's being trained with, the amount of parameters that you mentioned, just I can't quite fathom it. Honestly, it's mind blowing. And even though it's mind blowing now, I bet in 5 years' time we'll look back at the tech we're using now and everyone's going to laugh. Everyone's going to laugh at how we just had ChatGPT and a basic chatbot that didn't really do anything, very generic. So I'm excited to see where everything goes. So thank you very much. And if I can bring my screen up, perfect.
Yeah.
Okay, thank you, Cyril. Feel free to stay on or go off camera, whatever you like, and we'll bring you back for questions at the end. So we've seen quite a few questions come up in the comments, so don't worry, our machine learning hero isn't going anywhere. So, okay, so take care. Thank you, Cyril. All right, so we're gonna sort of pivot now a little bit to the developers in the room. So I am a developer. I am not a machine learning hero. Most of what Cyril said to me just then blew my mind, and I didn't know it prior, and I probably didn't retain as much of it as I should now. But AWS, they are expanding their LLM ecosystem more and more as the days go by throughout reInvent. So don't worry, these slides are very, very up to date. But what I want to do now is take you on a journey of what it's like to be a developer that wants to consume these LLMs. So we're going to treat them now as this black box that Cyril was just dived into for 30 minutes. And I'm now going to give you some advice and some direction as to how you can actually use them and build web applications, build Santa themed chatbots, build whatever you'd like. So let's just start with a definition of Bedrock. What is Bedrock? Is it an LLM? Is it different to an LLM? What is it? So at the top, Amazon Bedrock is a fully managed service that offers a choice of high-performing foundational models via a single API. So let's break this down a little bit here. And let's start with the model section. So it says high-performing foundational models. So you do not have access to just one model from one company. Parallels to OpenAI, and obviously they have all of their GPT models. You have access to the 3.5s and the 4s and whatnot. In Bedrock, you've got access to lots of other sort of public models. For example, from the LLM space, which we should all now know what LLM means, or at least what it stands for. So we've got some examples here. We've got Llama 2. Let me just bring up my notes. Here we go. Llama 2, so the 2023 model that has been built by Meta. We've got Claude from Anthropic, March 2023. We have Titan, which is AWS's own foundational model, which was released with Bedrock in September. There's also some text to image. So rather than having a text input and getting a text output, we also have a text input and then generating an image. You get an image back. So we have Stable Diffusion, a model from 2022. So almost a year, probably over a year old. And then we have Titan here again. So this is actually an announcement from reInvent this week that Titan now has an image generating model. And if you've watched the reInvent keynotes, you'll see the example where they say, generate me a picture of an iguana. And there it is, a high resolution picture of an iguana. And it's been completely generated by this model, which is absolutely mind blowing. So a lot of these models, as I said, 2023 or 2022, so maybe a couple of years old. But you can see there's a Llama 2, so there obviously existed a Llama 1. And Cyril mentioned as well through his timeline how this hasn't just sort of exploded right now. There's been a long history going, apparently back before Christ, but definitely to 1967. And he mentioned that Transformers was a large catalyst in explaining what we have today, which is true. But that was 2017. So why suddenly in 2022 or 2023 do we all now know what an LLM is? And the reason was, to be honest, from ChatGPT. And what did ChatGPT do that was so revolutionary? Well, technically not much. It's using those models. It was, I think it released with GPT-3. So it had 2 iterations beforehand, but just the public eye didn't really know. The difference was it created an interface, ChatGPT, which made it so easy where you just log in on the browser and you can just start asking this LLM questions. That was something that we hadn't seen before. And that is why we are now probably all on this webinar today. And so AWS are obviously trying to move into this space as well. So they brought out Bedrock in September, and they brought out a ton of other features literally over the last week that we're going to go through. And they're trying to solve the problem of making these LLMs more accessible to the developer in the room, like myself or Lorenzo and Cyril too, but Cyril's cheating because he knows how it works under the hood, and to most of us on the call. The next point, looking back at the definition, it's a managed service. So it's managed / serverless. So what does that mean to us? So there are no servers that you have to deploy this model to. There's no EC2 instances that you have to maintain and patch and train the model yourself. It's a base foundational model that is offered to you as a managed service, which obviously makes things easier to consume. And it's also serverless. So it comes with the benefits of, as I just mentioned, you don't have to manage your own infrastructure. It also scales. So you don't have to worry about scaling issues with any web applications that you build. And it works on a sort of a cost per use model. So here it's you pay a certain amount of dollars per token that goes into your model in your prompts and comes out in the response. So it also scales to 0, just like all serverless services do. And how do you access it? So it's now been integrated into the AWS API. So for those of you that are the cloud engineers in the room, building using your SDKs and building your Lambda functions and your containers running on ECS or Kubernetes, you have access to this Amazon Bedrock model. And there are 3 main commands that I just want to briefly go over here. Not going to get too technical. Not everyone here is a developer probably. But we have the invoke model command, where you simply pass in a prompt. You add some information, such as the model that you want to run this prompt against. and then you'll eventually get a response, which is the full response from your model. Now, as Cyril hinted at, there are some performance issues with LLMs. It does take some time. For those of you that have used ChatGPT, you can sometimes sit there for maybe 20 seconds waiting for a paragraph to come back. And OpenAI solved that problem in ChatGPT by having a streamed response. And so that's why there is another command you have available, which is to invoke the model with a response stream. And so what that does, instead of waiting for the full response to be returned from your model before sending it back to the client, you can instead set up a response stream. And so as tokens are generated, because that's how the LLMs work, they sort of generate tokens by tokens. That's our quantity unit. As they're done, they will enter the stream, and you can reduce that time to first byte, which means that you can get to the sort of the start of your response before the end of the response has even been generated. So obviously that's got some performance improvements, but it has a secondary benefit in chatbots, because you now get the illusion that the chatbot is typing back to you, because you get small increments of text coming in, looking like a conversation that they're just talking back. You don't get one giant paragraph in a split second on your screen. So it improves the readability, improves the experience. And so that's why it's quite a common use case in chatbots. That's why ChatGPT uses it. And then we have invoke agents, which I'm just going to park right now because I haven't told you what an agent is. That is going to be on a future slide. But we will come back to that. So let's talk about some of the features, the usability improvements that Amazon have brought out. And I'm talking about this week. So Amazon now have their RAG solution. So RAG, the Retrieval Augmented Generation. Now remember, I'm a developer. I don't really know what that means. But apparently, it's the AI framework for retrieving facts from external knowledge bases. So what that means is you have your base foundational model, your Claudes, your Titan, and you can now pass it specific data that you want it to have access to know about. For example, inside an enterprise, maybe you include your organizational structure. And so when you build a chatbot that tells you who you should CC on your emails, it knows who everyone reports to, it knows what everyone's role is, and can give you a good response. If you were to use a foundational model and say, should I include Sue in my CC, it's probably going to say, who the hell is Sue? But using Bedrock Knowledge Bases, which was generally available 28th of November, which is Tuesday, if my maths is right. I know how many days are in November. On Tuesday, it went GA. And with Bedrock Knowledge Bases, you are allowed to ingest data into a vector database, which is how the data is stored for LLMs. And it can come from within your AWS ecosystem. So you can simply throw it into S3, and Bedrock Knowledge Bases will translate it and move it into a vector database for you. And so again, let's look at a comparison with OpenAI. OpenAI relatively recently released the capability to have custom GPTs that you could create. So you create for a very specific scenario where it will do better than a base foundational model that has no specific information for the problem you're trying to solve. And then this is Amazon's answer to that. Now let's look at some examples of how I think AWS have even used their knowledge bases within their own platform. So those of you that are using the console most days for AWS will have noticed Amazon Q pop up on the right-hand side of your homepage. Amazon Q is a chatbot that has all the context it needs to know about AWS and how it works. Now, ask yourself, do you think a generic model, even Titan, do you think it knows the ins and outs of all of AWS's documentation and best practices well enough to give a high quality chatbot? The answer is probably no. So I imagine this has been a good use case for Bedrock Knowledge Bases, where all of that documentation has been specifically made available as an external source so that Amazon Q can give very, very good results for AWS related queries. Now note, this doesn't have access to your own resources. I'm going to say yet. I'd imagine that would be a great feature to have. So you cannot ask it to tell me which of my EC2 instances are running Ubuntu, for example. It can't see your resources. But if you were to ask it about a best practice or how do I do something, it'll probably give you a good response. And that's available now. Go to the console, you'll probably see it. Another example of how it's been used, for those of you that are querying your CloudWatch logs, there's now the Query Generator tab that has just magically appeared in our consoles, where you can pass it a human-readable requirement for what you want to do with your logs, and it will generate you, using the CloudWatch query syntax, what it is you're trying to do. And how's it done that? Well, it needs to have a very good sort of contextual understanding of how the CloudWatch query syntax works. I'd imagine that an external data source via a Bedrock knowledge base has been how they've achieved that. So those are two examples of how AWS has sort of demonstrated how easy it is to make to integrate the LLMs into their own platform. They had another great example to show you how easy and how user-friendly LLMs are becoming in late 2023. And it's on the next slide. So let's park that here. Let's talk about Bedrock agents. So another feature that went GA on Tuesday. It's on Tuesday. And it's to help developers with the sort of, it improves the developer experience. So Lorenzo and myself, we built this Santa-themed chat app. If you haven't seen it, you find it on all the Serverless Guru socials. Have a play with it. It's just sort of a fun hackathon example project. But the problem that we solved, problem that we had to solve, if we think back to those two methods, those two commands that we had available, where we could invoke our model or invoke our model with a streamed response, all we can do is pass in a prompt and get a response. And so what happens when you want to build a chatbot? What happens when you want to have the conversation chain? You don't want the LLM to not understand what you've been talking about previously. And the answer to that is to kind of bundle it all into this ever-growing prompt. And you have to do that all in code. So at the bottom here, think about if any of you have used LangChain, the LangChain conversation chain. All it does is takes your previous prompts, stores them in a data store, and when it comes time to build a new prompt, we'll just inject them all back in so that the LLM knows how your conversation has been going from start to finish. But now Bedrock Agents has been launched. And this is a service that will do all of that sort of hard work for you. So first of all, it has sort of an integration with these private resources via a knowledge base. So you can sort of build an internal enterprise agents to tell you who you should CC on your emails. You can now sort of build that very, very easily using a Bedrock agent. And now you don't have to manage all these different conversations. Yeah, and that's available now, Tuesday. So those are two features. We talked about the Bedrock knowledge base, and we talked about Bedrock agents. And I think AWS have got a fantastic example to demonstrate how user-friendly Bedrock and LLMs are finally becoming. And that is, hopefully, this slide. Yes. So I'll leave this slide open for just a few moments. If you want, you can scan the QR code. If not, I'm hoping Lorenzo can post it in the chat. Just give him a moment, I'm sure he'll find it. I've created a Party Rock application. And I'll bring it up in a second and just show you it and sort of tell you briefly how Party Rock works. Okay, I think I've given enough time for the QR codes. So Lorenzo, if you're there, just put this in the comment section. So I'm just going to unshare my screen and just bring up my next screen. So bear with me, everybody. Tab. Right, so I'm going to do this. Okay, perfect. Okay, so this is Party Rock. It is the Bedrock playground that AWS released a few weeks ago. It was actually just a fun internal tool that enabled the internal AWS employees to play around with Bedrock. But they loved it so much, the employees, that they managed to sort of convince the business, I guess, to release it to the world. And so what I've built here, and I kid you not, in 5 minutes, I built a digital nomad trip planner. So let me just talk you through how it works a little bit. You have all of these different fields where you pass in, you answer the questions that I've set. So where is your home, what your work commitments are, where you'd like to go. So I just put a few things in. So I'm based in London. My work commitment is Monday to Friday, let's say 9 to 5. The LLM will probably understand that. Where do I want to go? I want to go to Spain. I want to go to maybe Barcelona or maybe to Alicante, for example. When do you want to go? I want to go for Christmas. My duration, 2 weeks. What places have I liked in the past? I've liked Paris. I've liked Lisbon. Where have I not liked? I haven't liked. Be careful here. I haven't liked Munich. I haven't liked. I don't know. I haven't liked Glasgow. Let's say. Sorry for anyone that's from Munich or Glasgow. I'm just making this up as we go. So after our prompts have been filled, you can see here there's some magic working further down. And so we have an itinerary that has been generated telling us what our digital nomad trip should be. Day 1 to 3 in Barcelona. With all sorts of specific information about what you should visit, the cost of a private room. I even set it so that you get the average Wi-Fi speed because you're a digital nomad, you want to know these things. A safety rating, a workability rating, and whatnot. And you see that took quite a bit of time to generate. It did take about 20 seconds. So it's a good demonstration of the performance issues that we have to solve. I then generate a trip budget on the right-hand side, and I'll show you how the inner workings in a moment. And then I want to do a bit of fun. So I tested out the text to image models and then create an agent. So let me tell you how this works. So we can open up our itinerary section here. And you can see we've generated a prompt that is piping in our string values from our modals above. So our desired locations, which is this one, our time of year. So everything here. Once it's all been filled in, the model is then going to process the prompt. And I basically told it to create an itinerary. Yada, yada, it's not too important, just prompt engineering. That then generated the response. I have a trip budget. My trip budget, piping in my itinerary. So it waits for my itinerary to be generated. So it's now got another string. Using where is home and for my flights, generate me a budget, which is great. My trip map, create a world map that includes the locations in my travel itinerary. So not a great response, it isn't really a map, but it looks somewhat like Barcelona, I guess. So, okay, not too bad there. And then you have this agent. And so this is where I think Bedrock agents has come into play. So I've now got this agent. So if I say my name is Sam, so this agent, let's open it up. So there's an initial message, and then I'm sort of have like an initial prompt, I guess. And then you've got this agent where you can have a conversation with. So I've said my name is Sam, and it says some useful things about where I'm going, what to pack. Let's test it. Let's say, what is my name? Let's see if this works. It doesn't know my name. Okay, so here we go. So it knows that my name is Sam, so it has my conversational history. So this is how you can then use your agent to create what looks like a chatbot. So that's one part of the fun, how I created this in 5 minutes, no exaggeration, but also the nature in which I created it. So when you go to create one of these, and I won't do it on the spot because it takes too long. Let's unedit, go to my apps. To generate this app, you give it a prompt. And then the prompt is using Bedrock to then generate your web app. The way that it works is it uses some very smart prompt engineering to take what you've got here. It passes it some context, being some classes or interfaces to implement in code. It says implement those classes based on the requirements here. Those classes output a JSON configuration, which include things like the type of modal, whether it's a string input or whether it's going to be one of these agent modals, the sizes, the positions on the screen. And all of that gets passed into a system that then just generates the UI you see here. And I had this in 5 minutes. So yes, it's a fun little playground, but I think it demonstrates how accessible LLMs are becoming in the AWS ecosystem. So I will unshare the screen and we'll very quickly move back to the slides. We're almost there. I'm aware that we're at 7 p.m. my time, which is when we're supposed to finish, but it's a Friday evening. I don't have a lot on. Perfect. Okay, let me try that again without the border on the top. Chrome tabs. Let's try that. Okay, that's better. All right, so that's the demo. Again, QR code, or you can find it in the comments, hopefully. If not, you reach out to me on, or probably on LinkedIn is the best way to find me. I can share it with you. Maybe I'll put a post about it. Anyway, okay. So let's now get a little bit more technical. So we've looked at, we've sort of well-defined what Bedrock is. It's an API where you can prompt and response, or prompt and image. We've spoken about some of the features that make it a bit more usable, so Bedrock agents or the Bedrock knowledge base. Now let's look at some architectures. Let's look at how you can build some of these web applications. Let's look at a very simple example here. Apologies, I'm not a designer, so bear with me with my designs. You can have a very simple client speaking directly to a Bedrock agent. It'll be using the invoke agents command, and it'll be getting some kind of streamed response back. That Bedrock agents can be integrated with a Bedrock knowledge base, which is essentially a vector database behind the scenes, and you can load that with data from S3. The service does that for you. There are some problems with the client, so you can directly to the Bedrock agents. You don't really have much control. The client can kind of pass whatever it wants. It's a little bit risky. And you probably want to put an API in the middle of it. So you can have your client maybe making a REST request to a REST API gateway. Backed by Lambda, let's keep things serverless. Within that Lambda, you can maybe call to invoke agents or invoke model if you're going directly to Bedrock instead of an agent. And again, you can have all of that integration with Bedrock, a Bedrock knowledge base to give you a better context around the problem you're solving. Problem with that, as I said, performance. If you have to wait a good 10, 20 seconds to get a response back, it's a very bad user experience. And so you want to have some kind of streaming response back. And with the nature, the call and response nature of REST, maybe it's not the best use case. And I say maybe because this tech is so new, literally this week. I don't think the industry has figured it out yet, which is why this hackathon, I think, is such an exciting time to be running this hackathon. And for those of you taking part, such an exciting time to be innovating, solving these problems, because the community hasn't figured it out themselves. But from a REST, maybe you could do WebSocket. The benefit of WebSocket is it's sort of bi-directional communication. So you can do from a client, send message, saying to tell me a story. From within your Lambda function that gets invoked, you can invoke the agent, or better, invoke model with the streamed response. I can go directly to Bedrock. Again, could be using Bedrock knowledge bases. And then you start getting back your tokens as your tokens get generated for your outputs. And then your Lambda function can directly send those tokens as it receives them back to the client, because it's bi-directional. There is no call and response. It's call and response, 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 response. And so you get a better time to first bytes, and you get that illusion of a typing chatbot, if that's what you're building. So those are three of the architectures that I came up with, Lorenzo came up with, but I kid you not, it's an exciting time to be in this space. So for those of you on the hackathon, start solving some problems and see if you can improve upon some of these sort of agreed architectures that the industry currently has. So I'm going to pause it there for Q&A. So I think we maybe have collated some questions in the chat. Lorenzo and Cyril, if you want to come back on stage, you are welcome to. Thank you, Cyril. Thank you, Lorenzo.
Hello, Sam. Hello, Cyril. Thanks a lot for both of the presentations. They were really great. I learned a lot. There was a lot of information, a lot of details from your presentation, Cyril, that I was not aware. So thanks a lot for that. Now let's jump straight into the questions. I wrote a few down from the comments during your presentation, Cyril.
Yeah.
Two of them are from Craigmont. Craigmont, thanks a lot for being so active on the chat. Where the first question would be, he missed the difference between ML and DL. Would you be able to give your 5 cents on that? How would you differentiate them?
Yeah, so machine learning is the subset of artificial intelligence, which uses data, and deep learning is the subset of machine learning focused on neural networks. So you could use linear regression to do machine learning, as well as you could use neural networks to do machine learning. And whenever you talk about neural networks, you are talking about deep learning. And any other thing which is not neural networks under machine learning, trying to predict with data, is the traditional machine learning. So you have models like linear regression, XGBoost, CatBoost, all the other support vector machines, k-nearest neighbors. Those are normal machine learning models, not deep learning machine learning models.
Perfect. Thanks a lot, Cyril.
Yeah.
Yeah, it's almost the same response that Gonzalo gave on the chat, stating that the difference was the first letter, but we can see that we actually have a little bit more of that. The other question also from Greg was if there was a minimum amount of info needed to become a large. So we have large language models. What actually is the difference from language models or jumping straight into large?
Yeah, yeah, like I said in my presentation, it has to do with billions of parameters. Yeah, that's when you start talking about large models. Large language models, yes, billions of parameters. Below that, yeah, you could use traditional machine learning models to get your answer, but above that, it's complicated. You need transformers.
Perfect.
Yeah.
And now I guess a question for both of you, or maybe Sam, since he started to work in speaking about it. We have a question from Bike, Backpack, and Scout. Not sure the real name, but at least that's a funny one or an interesting one on YouTube, where he asked about agents. How would we different agents, or what could we say the differences between agents and LLM itself?
Do you want me to take that one, Cyril? Yeah, I'll give you your voice the rest quickly.
Yeah.
So the agent's kind of a wrapper around, and it's a sort of an interface to talk with the LLM. So whether you use an agent or whether you directly call the invoke model command, you're going to be sending a prompt to an LLM and getting a response. Because at a very high level, that's all that they do. The difference is that the agent is going to do a lot of the hard work for you. So the agent will store your conversation history. So the last prompt, the prompt before that, and the answers. It will store all of that somewhere. And when it comes time to build the prompt, it will feed all that in. Let me give you an example. If I am talking with let's say I'm on booking.com and they have this LLM-powered chatbot that helps me decide where I want to go. If I say to them, hello, I would like to book a holiday this summer, they would say, okay, I would recommend Spain. I would recommend Barcelona or Alicante, for example. I then say back, that sounds great. Is it hot? Now, if I am just using invoke model, invoke the invoke model command, the first time I said, hello, I would like to go on holiday this summer, and got a response saying Spain or, for example, Alicante. My next request out is saying, that sounds great. Is it hot? And that is all the LLM would be getting. It'd be getting the phrase, that sounds great. Is it hot? The LLM is thinking, is what hot? What sounds great? What are you talking about, Sam? And so what the agent does is it's going to take in my previous question with the answer, put that at the start of the prompt, probably wrap it and say, this is the conversation. And then new prompt, that's great. Is it hot? And you'll pass that whole block of string, that whole text into the LLM. And so the LLM now knows what we're talking about. It knows that we're a travel agent, or it knows they're a travel agent. It knows that we're talking about a holiday to Spain. And now it needs to answer, is Spain hot? So that's one of the problems that these agents solves, is making it more like a chatbot rather than just a simple call and response. So does that answer your question? And Cyril, if I misspoke on anything, please let me know.
No, it's great. It's great. It's perfect. Yeah. Thanks.
Yeah, that's a great response, Sam. And just to give a little bit more context now that it's out there, generally available, there's also a few great articles out there where they explain how you can use the agents to, for example, get your LLM to do requests to your own API. That's something fairly interesting that would be nice to see if anyone is actually able to integrate it as part of the hackathon itself. Another interesting question from Gregmont was, Cyril, you talked about the hallucinations that the models can have. He asked if there was some approach to limit those hallucinations. I know there are the input arguments of, for example, temperature, top P, top K. Do these have something in common?
Yeah, that's the whole point, because machine learning is all about data, garbage in generally, garbage out. So it it's not magic, it can't say what it doesn't know. It's a machine, remember. So with hallucination, you can do things like the prompt engineering we said, just to try to guide the output towards a specific output. But then it all goes back to your training. You're trying to train the machine learning model to be able to do stuff. You give it the wrong data set, then it's just going to guess with less accuracy because it doesn't have the context, it doesn't have enough information. So you can use things like racks, as Sam is saying too, still, to be able to fetch data from other sources to feed it, because it's not a sorcerer. It's just taking data, and if it doesn't have it, it's going to give the data, because it like kind of ranks the data in terms of confidence level. And if you've been using maybe the old models, it's like, okay, I'm 90% confident, I give the highest one, 99%. So if it even has a 50% or 40% confident and the rest are 1%, it's just going to throw the 50% to you because that's the highest. So that's just something we keep pushing to make our models have the right data set, the right context, and use racks and some interesting prompt engineering to do the in-context learning. That's the difficult part. Yeah. Garbage in, garbage out. Yeah.
Yeah, I really like that phrase, and I think Jonathan also liked it a lot with his comment comparing it to the diet. That's something really good to take in mind when working with LLMs. Also, something that I really liked from your side was when you talked about that it's basically just probability. So depending on the amount of data that you have and how you have trained it, it will say things or another. For example, I faced the issue trying to get examples for code examples for AWS SDK 3, version 3.
Yeah.
I've not found any, nor MSMQ being able to actually generate it. It's trained with V2, then it tries to do V3 just by importing V3.
Yeah, exactly. Yeah. It needs the data to be able to tell you, give you the response. Yeah. Thanks.
Perfect. And then just wrapping up with the last question from Craig Mont again. Asking Santa chatbot is a lot of fun. How long did it take you guys to set it up? We didn't mention it during the last one, but we'll be talking about it in the next webinar. So next Friday, December 8th, we'll be talking about the different technologies that you will be able to use to actually replicate or build your own chatbot. And on the 15th, we'll actually do a deep dive into all the code. You'll be able to see the code, the structure, how we are, the architecture that we chose, and why we chose everything. But just answering directly, Craigmont, to get something up and running that works, you could have something in 5-10 hours, maybe less. Then it just depends on, okay, do you want to make it secure? Do you want to make it look beautiful? Everything that you want to add will just add a little bit more time.
Do you want a streamed response? I know we said it a few times. Yeah.
Exactly. But don't worry, Craigmont, we'll go into more detail on next Friday on the next webinar. And also feel free to just jump into the Discord and ask questions if you start developing or doing your own application. Then I think we're all already over time. Thanks a lot, everyone, for joining. And I'll leave it up to you, Cyril and Sam, to actually, if you want to wrap it up and give a few last words or advice.
Go on, Cyril. You go first. You go first.
Yeah. Okay. Yeah. So I just think the key thing is it's not magic. It doesn't solve, like, it's not a one size fit all. It's not like invalidating everything we know. LLMs doesn't come and like invalidate everything we've ever known in history. It's just here to solve a problem, and we just have to begin with the end first. What problem are we trying to solve? And if we're going to be using LLMs to solve the problem, okay, that's fine. If you will be using GANs, or if we're using traditional machine learning models, we just start with the problem and we are able to choose from. We just have more options now. And again, remember, the major thing is the data. It's always, your model is as good as the data you feed it. again. So still garbage in, garbage out. Thank you. Yeah. Thanks. You can take it away, Sam.
Yeah, nothing to add. We'll leave it on that note. So I guess thanks for joining. We'll be doing this 2 more weeks, same time. See Lorenzo and myself here. Next week we've got a different guest speaker talking more about a bit more into the developer experience. We've got somebody that's been part of a sort of a open source LLM success story. I won't reveal too much more. If you follow us on socials, you'll see the reveal for who that is next week. Yeah, super excited to hear what they've got to say on how you build services using LLMs.
Yeah. Thanks for having me. Yeah.
No worries, Cyril. Thanks for jumping on. I know you're stuck in Las Vegas at reInvent, but thanks for giving us an hour or so of your time.
Yeah, thanks. Okay.